Okay, this video accompanies the mathematical literacy and vocabulary pages. So let's see what we got. So we want to complete the table by filling in the missing information. So an angle pair, two angles that are related in some way, congruent, supplementary, corresponding, exterior, interior, vertical angles, or linear pairs are all examples of angle pairs. Parallel lines are two lines that never intersect. They always are the same distance apart. And over here we have a couple of examples of parallel lines. Notice that the lines that are parallel have corresponding arrowheads on the line to show that they match up. I could match these two up like this with two arrowheads. I could have another pair of parallel lines come through here and maybe mark those with one arrowhead. So one arrowhead marks a pair of parallel lines, two arrowheads mark a pair of parallel lines. Let's look at transversals. A transversal is a line that crosses two or more other lines. So this is an example of a transversal that happens to be crossing two parallel lines. We also get to have two lines that aren't parallel and a line that crosses, and this would also be the transversal. So those are transversals. So all it takes to be a transversal is a line that crosses two or more other lines. Congruent, two angles are congruent if the angles have the same measure. We could look at a right angle, for example, and let's bisect the right angle. I'm going to mark these two angles as congruent. So if these angles are marked as congruent, that means they must have the same measure. And if we have angle A, so the notation would be two angles that are congruent. We'd say angle A is congruent to angle B. The measure of angle A is equal to the measure of angle B. Comes from the definition of congruent. And there's a transfer property of congruence. If the measure of angle B equals the measure of angle C, and the measure of angle C equals the measure of angle D, then, put an if out here in front, then the measure of angle B equals the measure of angle D. And this is an example of what we would call the law of syllogism, which is the same thing as the transfer property in algebra. The C connects together and leaves B and D linked together as having equal measures. Supplementary angles are two angles whose measures add to 180. We could have a linear pair of angles. These two angles would be supplementary. They're adjacent because they share a common side, and their other sides make a straight line, which gives the 180-degree measure. We also could have two angles that sit independently from each other. Let me draw these two here. Let's call this angle A and angle B. Now if angle A's measure plus angle B's measure adds up to 180 degrees, then they are supplementary. So we could say if the measure of angle A plus the measure of angle B equals 180, then they are supplementary angles. And they are supplementary. Let's look up. Alternate interior angles are two angles that are on alternate sides of the transversal in a system of parallel lines, or in a system of lines, two angles that are on alternate sides of the transversal and inside the lines that are crossed. So in the diagram, this is a pair of alternate interior angles, and also we have another pair of alternate interior angles on the other side. So these are alternate interior angles marked with double marks. They're going to be congruent to each other because the lines are parallel. And these angles are alternate interior angles. They're going to be congruent to each other because of the parallel lines. We also could have alternate interior angles that are formed by a system of lines in a transversal where the lines are not parallel to each other. Angle 1 and angle 2 would still be a pair of alternate interior angles, as would angle 3 and angle 4. These would be alternate interior angles, but we couldn't say that they were congruent because alternate interior angles are congruent if and only if the lines are parallel. So let's say alternate interior angles are congruent if and only if the lines crossed are parallel. So if we have parallel lines cut by a transversal, these alternate interior angles have to be congruent to each other. If we have lines crossed by a transversal, we can talk about them being alternate interior in terms of their position, but we can't say anything about their measures being equal unless the lines happen to be parallel. Corresponding angles are, I call them same side, same side. And with parallel lines cut by a transversal, corresponding angles are congruent. So these two angles are corresponding angles. This angle 3 and this angle 4 would be a pair of corresponding angles. This angle 2 and this angle 5 would be a pair of corresponding angles. And this angle 6 and this angle 7 would be a pair of corresponding angles. So corresponding angles are congruent. Now, another way we could have corresponding angles, before I get started on that, two lines that are not parallel to each other, angle 1 and angle 2 would be a pair of corresponding angles. Angle 3 and angle 6 would be a pair of corresponding angles. They're both on the same side of the transversal, and the purple ones are both below the lines that are crossed. And on the left-hand side, 1 and 2 are to the left of the transversal, and they're both above the lines that are crossed. So they're in corresponding position. So you can say that corresponding angles are congruent if and only if the lines crossed are parallel.